Designing a messaging service like WhatsApp, Facebook Messenger or WeChat is a popular system design question. Stay tuned. Usually 1 out of 5 or 6 interviews is around system design, and in this case we're going to take a look at designing a messaging service like WhatsApp. As with every interview question and as with every system design interview question, those questions are super broad, and don't get into the rabbit hole and start talking about just one topic in the beginning. Spend a couple of minutes to find out what exactly the interviewer wants to hear from you. So normally they tend to look at how well you ask questions in the beginning and then how you tackle the problem and tackle all the facets of this problem. So in this case, designing a messaging service that can range from a super simple messaging service like a chat app between those two people, but you could talk about designing a messaging service with all kinds of features, maybe videos, maybe voice, and scaling it to millions and millions of people. So what kind of questions should you ask the interviewer? In something like this, it makes total sense to ask about features first and then derive the architectures from those features. So with WhatsApp, we could say we want a messaging service to be available on mobile phones, and we want one-to-one messaging with just text. This could be our baseline, and from there on we could add features later. Now let's write down some of those features. Okay, so probably the most important one, we want to have messaging between two parties, no group chats at the moment, and just text. Another one could be, which is really nice and something that WhatsApp was doing for a long time, is having a sent confirmation, a delivered confirmation, and a read confirmation. So maybe if you use WhatsApp, you notice those check marks at the bottom at each message. First one means message was sent, so outgoing from your phone, your device. Second check mark means it was delivered to the recipient, and when those two check marks go from gray to blue, it means the message was read. So at least the recipient opened up the messaging app and saw your messaging thread. And then a third feature we could talk about is push notifications. So push notifications is a little bit different than this kind of stuff, because all we want is a notification on the device as soon as a message comes in. So we're going to talk about it later. Push notifications have some characteristics which differ quite a lot from the rest of this messaging stuff. So one more thing before we start here. Of course, nobody expects from you to design one of those huge applications full-fledged on the whiteboard. It's only 1 hour, so you can only touch so many subjects, right? Still, it's a good idea to have a good understanding, or at least an idea, of how systems like this are designed in reality. And there are some very good resources out there which help you, and they're also super interesting to read. One of them is the High Scalability blog, and another one is a page called Hired in Tech. Both will be linked down in the description of this video. So now to the design of that first feature. We want to have two parties communicating with each other with just text messages. So that means we have two devices, both are connected to the internet. In between there will be something like a server, because what we want is, even if that second party is not online, we want to have messages being sent through, and then when that second party comes online, as soon as he's online and connected to our server, the message will be sent to him. So very broad, we have Bob and Alice. So those are our two parties, and they want to exchange messages. So with a server in between, storing messages and storing messages of those two, the bottleneck will become this server in the middle. So whenever we want to scale solutions like that, we have to think about being asynchronous. So meaning those three elements don't have to be synchronized at all times. And the second thing we should think about is scaling horizontally. So instead of adding compute power to this middle component here and making it bigger and adding more RAM, adding more memory, adding more power, we are adding multiple of those components next to each other. And in an ideal world, it shouldn't matter to which server Alice is connecting and to which server Bob is connecting. And in one conversation, they should be able to connect to whatever server there is at this moment and whatever server has capacity to serve them. So now you see we have three servers, and you could think about sending a message to this one, and as soon as Bob comes online, this one will be delivered from this server. So what do we need in each of those servers, or what do we need as soon as one of those servers will start to serve one of those two parties? There has to be something like a queue in here, right? Because what we want is to deliver a message to this server and then deliver it to Bob. And let's say we don't want to store all the messages in the server, and that's something you have to discuss with your interviewer, because maybe it is a requirement to store all the messages for like a history or audit purpose in servers. But to optimize for storage, we could say we only store in servers what is needed at the moment, and as soon as we deliver to Bob, we can delete messages in the server. So now let's look at one of those servers in detail. So one of those servers could look like this. You can have a number of queues in that server, and those queues themselves are also ephemeral, meaning if they are empty, they could be released and could free up space. And those queues are mainly to store messages from a person like Alice. So let's say Alice sends a message, and this is Alice's queue, and there is one message in there. And Alice wants to deliver to Bob. So now as soon as Bob comes along, that message will get put out of the queue to Bob. And the queue itself could be deleted, and also the message will be deleted because Bob already retrieved it. And in reality, that's exactly what WhatsApp is doing. They don't store messages for you. As soon as they can deliver, they will deliver, and then they get rid of those messages in the server. Okay, now we have a rough design of servers, multiple servers being horizontally scaled, and how they relate to those two parties. And let's think about a characteristic you maybe have noticed in WhatsApp or other messaging apps. When you send a message and you are offline at this moment, or maybe the other party is offline, it can happen that messages get delivered in the wrong order. And that's exactly what can happen with architectures like that, because possibly while you send the first message and you're Alice, you were connected to server 1 up here, but server 1 couldn't deliver to Bob at this time. Then you send a second message, and at this time, because server 1 was just not available for you, maybe you moved and you moved out of a region, or maybe that server has too much load on him, then the second time you were connected to this server. And now this server has one of your messages in this queue, and this server has one of your messages in his queue. And now Bob comes online. And now this is like a race between those two servers, because This one will try to deliver, and this one will try to deliver to Bob. And of course, now it can happen that server 2 delivers first and server 1 delivers second, and then your messages arrived here in the wrong order. Okay, let's move to the second feature now, because we talked quite a lot about one-to-one text messaging. Of course, there's a lot more you could talk about, like making that architecture faster and scaling it in different ways, or using caches somewhere, maybe using history and audit servers to store message logs. But let's move on to the second one. So, second one is a send, delivered, and read messages. So what happens here? You could imagine that when sending a message to the server, because it's some sort of a connection, it will be something like a TCP connection. The server will reply with an acknowledgement that he received the message from Alice. Okay, so this is an ACK. This is the message, and this is the ACK coming back. Now with the acknowledgement coming back from the server to Alice, we have this part, the send part, already done. Because at that moment, we can put one check mark above or below our message. Now the deliver check mark, it's a little bit more complicated, because let's say the message is in this server, it's in that queue. That queue belongs to Alice. Only when this server can deliver the message to Bob, we have to open up a second connection, or at least we have to connect to Alice just to send the delivered check mark. So at some point in time, when this server connects to Bob, delivers that message, there will be a second connection opened. Just to send the delivered check mark. And of course, again, Alice would send back an acknowledgement to let the server know that this check mark was sent correctly. Okay, now that's here. And what about the read? So the read check mark will happen again as soon as Bob opens his phone and reads the message. And he will need to send the message over a server to Alice. Now, you could imagine that using, also for the delivered and for the read, you could use a message instead of the same server going back. You could use a special kind of message, and you could queue it the same way and send it to Alice, because it doesn't matter which server tells Alice that a certain message was delivered, right? So you could imagine that Bob, without him typing it, of course, sends an acknowledgement with a message ID to a server. It will be queued like a regular message. So it will be queued in one of those servers, and we have ACK in here. And it will be delivered to Alice. And it doesn't matter which server it has to be, which is very much what we want, because we want to be agnostic of which server we're using. Those servers should be should have no difference, because we want to turn them down, we want to be able to upgrade them, we want to be able to hot swap code on them, and we want to add more if there's, for example, a spike in traffic. So that's maybe not a bad idea. Same for the delivered message. We could just use a special kind of message which the server creates and sends to Alice. That's it. Okay, that's the read. Okay, now on to push notifications. Push notifications, if we think about them, they are pretty different from text messages, because push notifications, of course, they have to be delivered as text messages when the recipient is online, but at the same time we don't expect any interaction with those push messages. So as a server, all we want is deliver it and getting some sort of acknowledgement that the recipient received that push notification and that person's phone showed it. So in reality, what WhatsApp, for example, does is using Google's cloud messaging platform to deliver those push notifications. Because of course you don't want to implement everything on your own. And if somebody like Google and you're working on Android, on a platform like Android offers something like that, chances are that you want to use it. So push notification probably would be a totally different system than this one, and you want to optimize it for this one purpose of sending notifications to all kinds of people. So you could imagine that when a server receives a message, he stores or he sends a request to another system which is only there for push notifications. And this one will send out the message to that person's phone. And to optimize this a little bit, you could imagine that sending the push notification gets delayed until that server has capacity to send this push notification to that other system. Because push notifications themselves, they are of course somewhat time critical, but people don't expect the same accuracy as for one-to-one text. So this is striking a compromise and striking a balance between what's your first and foremost goal. In this case, it's delivering the text message as soon as possible. And also, push notifications themselves are by nature fire and forget. That means the server sends them, and as soon as he gets the acknowledgement that the recipient received it, the server will delete it from his queue and never try to send it again. And he probably also doesn't have to store that push message or any record that he sent the push message. Besides, of course, if a service like Google Cloud Messaging or the cloud messaging platform will log metrics and data about how many push messages were sent, for what purpose, and to what recipient. That was feature number 3. And now, if you still want to dive deeper into other topics of messaging services, you could think about a couple of topics. So one of them could be having group conversations where you have multiple recipients for messaging, so broadcasting messaging. Of course, you could also talk about just scaling more and scaling for millions and even billions of users. Then topics like maybe caching or database replication, database sharding and stuff like that will be more interesting. On the topics of databases, it could be worth to talk about storing messages and having a message history or message log on the server side. But also it could be worth talking about having backups, so client-side backups for messages. Something that WhatsApp really offers is connecting to services like Dropbox or Google Drive or iCloud to store backups of messages of users. And finally, what you could also talk about is monetization. So again, this is, and I mentioned it in this other system design interview, this is maybe not something you'll be asked as a junior developer, but if you're in a management role or if you are in a product management role, it's going to be mainly about how to design the product, of course, and monetize it, and also show some technical knowledge. So WhatsApp, as you know, is advertisement free. Even after Facebook bought it, they're still advertisement free. But you could think about stuff like Asian messengers like Line and WeChat do when they sell stickers and emojis. And you could talk about usage limits, you could talk about premium services and all kinds of stuff. Let's not forget about things like load balancing. So although we didn't draw it on this picture, between the server and the parties there will be some sort of load balancing, because the load balancer then will decide which server, which messaging server will serve that customer. So here and here there will be layers of load balancing and also maybe layers of caching for other services which deliver content to the customer's devices. Okay, this is today's video. I gave you a quick rundown of how to design something like WhatsApp or Facebook Messenger. We looked at 3 core features and we also talked about some of the more advanced topics. And as a quick summary, don't forget, if you ever get asked something like this, take a step back and think about the features first and then derive from those features the desired architecture. And it's absolutely okay if you start with some simpler features first and then grow the architecture and grow the feature list as you're progressing in that interview. And the interviewer will give you a lead and will give you some guidance on what topics he wants to hear about. And just keep talking and keep asking questions. If you liked today's video, please give me a thumbs up, subscribe to this channel. My name is Ramon Lopez and this is Success in Tech.